The Spinoff Podcast Network.
K-pop to me means more than just listening to music. It's learning to be myself.
The Spinoff's new documentary, K-Pollies, follows 3 Pacific youth obsessed with K-pop. In a one-off documentary, see what they've found in Korean pop culture and how they bridge it with their own.
When you start dressing, looking different, everyone side-eyes you. But in K-pop, they're just like, no, like celebrate yourself.
Watch K-Pollies today at thespinoff.co.nz/videos. Made with the support of New Zealand On Air. You're listening to Business is Boring, a podcast that reckons it's anything but. Business is Boring is brought to you by Spark Lab, offering inspiration and practical advice to help businesses find their edge. To hear more about Spark Lab, including details about the latest events, workshops and business tools, visit sparklab.co.nz. And now, here's your host, Simon Pound.
You're listening to Business is Boring, a podcast that reckons it's anything but. Business is Boring is made by the Spinoff with help from Callaghan Innovation, New Zealand's innovation agency. Here's your host, Simon Pound.
Tucked away in Parnell is an innovation centre that has helped propel some of the biggest names in local tech forward, although you might not have heard of the place or even some of the names. It's a truism of the local scene that some companies are easy for the media to cover, and some, like many facets of science and technology, are a little complicated and don't get the airtime. This hub used to be a DSIR building, and it started to let space to projects with interesting science, and they've gone on to be unusually successful. Some you really have heard of, like Rocket Lab. Some you might know, like Lanzatech, one of the great undertold stories of the local scene, and some you'll be hearing a lot more of in the future, like Imche Innovation, who are turning e-waste into literal gold. The importance of fostering this creativity has meant that what started as an accidental meeting of minds has become very purposeful, with the space now operating as Level 2, an incubator specialising in deep technology. What's that? Well, to find out and talk tech, incubation and the next crop of great ideas, Imche Fouri, General Manager Innovation, and Dr. Will Barker, CEO of Imche Innovation, join me now. Thank you so much for joining me. Hey, so first up, what got you into the tech incubation space? Imche?
Thanks, Simon. A series of wildly unpredictable events, as these things tend to happen. I started out as a biotechnologist. That was my background. Loved science, loved the way it can transform the way things are done. So I pursued a science degree, ended up going into research with the Centre for Brain Research and hated every minute of it. Hated being stuck in the lab pipetting all day. I wasn't dealing with people enough. So I started out sitting on a couple of the return on science investment committees, getting involved with early stage investment that way. Met Will somewhere along the way, and Level 2 just kind of happened. I had an interest in how science travels from benchtop to marketplace to people who really need it. And during that process, early stage investment, incubation is pretty important. So I've always had a leaning towards that.
And in so many kind of tech spaces, people invest ahead of revenue. But with science, you've got investing ahead of revenue, often also investing ahead of actually knowing if the thing that you're thinking about is going to work, if it's ever going to find a market. It must be such an interesting process to get involved with, those investment committees and those early stage companies and see those like first sparks turn into companies.
No, it absolutely is. And it starts with the idea first. It always does. And the theory follows shortly after. That's when early stage investment tends to get involved, when there's a great idea, a great founder or scientist, and they just need a little bit of scope to test it out. And that's what I find really exciting. Yes, we don't know if it's going to work. That's part of the excitement. but also part of why investing in deep tech early on is difficult for a lot of investors. What do you think, Will?
Yeah.
I absolutely agreed. Yep.
Yeah. Let's bring Will in here. Hey, what's your background? How did you come to be in Parnell, Auckland, New Zealand?
Sure. So mine's a bit of a longer story. A little older than Imche, but you can probably tell by my accent I'm English originally. Completed a PhD in England in synthetic chemistry. And came to New Zealand originally about 20 years ago as a working holiday to postdoc, a fairly typical journey for a scientist. Had every intention of returning back to the UK and I guess making it big in the pharma industry. Just fell in love with New Zealand, as a lot of expat British do, and just very, very passionate about science still. And had to working in science in New Zealand is a challenging space. There's not as many opportunities as there are in the UK, so I had to be a little bit more creative about starting a career. Had a bit of a meandering, I call it a career in inverted commas, for a few years. Worked in forensic science for 4 years, busting meth labs. Then moved to become a patent. Took a proper job working as a patent attorney. Worked for a local patent attorney firm, and that's when my interest in commercialisation really started, and became a lot more involved in intellectual property, in a lot more how you leverage the value of science. From there, I spent about 7 years in Lanzatech, as you mentioned earlier in your intro, a very successful biofuels company that was founded here in New Zealand. But recently, about 4 years ago now, moved all its operations and HQ out to Chicago to continue its commercialization story. I took that opportunity to step out and look for the next venture to become involved in, to get started with. Looked at a lot of different technologies around New Zealand, a lot of publicly held technologies, a few privately held technologies, and didn't really find what would really lit my fire. So what I ended up doing is myself and a colleague kind of went back to basics. We're really interested in the clean tech space, taking waste and creating some value. Learned a lot of very important lessons from Lanzatech about creating value from waste, and how to really give yourself a head start in that space, and that's how we kind of slowly evolved into the idea of Mint Innovation, which, as you pointed out, we take waste material, in our case electronic waste material, and then we recover gold and other valuable metals from that waste material using a mixture of chemistry and biotechnology, and that's where we are today. We're kind of part way through that journey.
Let's jump a bit into what Lanzatech has done, because it might have popped into people's radar as one of those examples of a Kiwi company that then ended up moving offshore. But I don't know if it's as well known as it should for its actual scale and the amount of investment it's had and the people it's dealing with, because it's had hundreds of millions of dollars of international investment. It has hundreds of patents around the world, and is probably on the edge of doing some really significant stuff. What does it actually do?
Yeah, sure. Great question. And you're absolutely right. It's a phenomenally successful company that is little known because it's on the verge, if you like. So they take, in the first instance, they take carbon-rich gases. Those are waste gases from industrial processes. In the first instance, that's steel mill waste gas. That's the gas that you see being flared out at the top of those dirty steel mill pictures that you see on the internet. And because they're being burned, these gases, there's carbon and energy in them. And what Lanzatech is taking that carbon and energy and putting it through a biological process. And you've got these tiny little microbes that take the carbon and energy and convert it through to biofuels and biochemicals. The journey started probably more than 10 years ago, 15 years ago now. And it's a typical, typical clean tech story. Starts with a small amount of investment, small team, proof of concept, raise a bit more money, R&D, scale up, pilot plant, raise more money, bigger team, demonstrate the technology at scale. And they're actually commercializing now. So they actually do have a commercial facility in China now. It's 4 years since I've been at the company, but I understand they're doing very well. And that first commercial facility enables them to springboard to multiple facilities around the world. And that is true success in the clean tech world. Yeah. They continue to be rated the number one clean tech company in the world, a company I'm very, very proud to have worked at. But the amount of experience that you gain in working for a startup like that, a successful startup like that, is phenomenal. And there's a very large number of staff who have kind of been part of that Lanzatech story and have stepped out at some stage to do their own thing and use those skills, leverage those networks, and start their own companies. And Mint is one of many.
Yeah, and that's the thing, isn't it? Where when the argument talks about people going overseas, but the intellectual property, the understanding, the networks, and the experience go on to then foster so many new companies in the ecosystem. And I love the way that you said that it's very typical of a clean tech story, because it's so cool that a couple of people read a science paper about, was it a rabbit gut microbe, and they were like, maybe that could be the thing that could turn smokestack pollution into ethanol, and then 15 years later it's happening. But it takes 15 years and a lot of investment to even turn $1 of revenue.
It's correct, and that's absolutely right. It's a happy coincidence of a series of events. One of the co-founders lived near a steel mill, Glenbrook Steel Mill, sees the flare being burned on a daily basis from his back garden.
Yes, there's a lot of energy in there. We could use that for something.
Exactly. They're both biotech. The founders are biotechnologists. They've both got backgrounds in this. They start doing some digging, start identifying where this can go, and it's just a privately held tech in New Zealand is always comes out of those kind of happy kind of coincidence of the right people coming together with the right ideas and creating it. Privately held tech, and that's level 2's speciality, if you like, is a challenging space, because you've got your average people who've got neat ideas that do need lots of money, lots of space, lots of infrastructure to develop. So sometimes it works out and sometimes it doesn't. But the Lanzatech story has been pretty phenomenal, wild ride for a lot of people.
And to go into that level 2 idea, so having been through that experience, and you, Imche, having had the experience of working with early stage companies in the investment space, what made you decide that level 2 was what was required? And what's special about it? How does it work?
We didn't really make that decision. Level 2 started out from a very organic need. There was a need for space. There was a need for startups to work together. And level 2 just started by a happy accident. The first private company on site didn't start there started there 20 years ago. So we've been a home to deep tech startups for 2 decades. No one decided that that's what New Zealand needed. It just arose out of a need.
And in the formalising it into level 2 and the creating kind of the incubation part?
Also out of necessity. DSIR turned into IRL, which then turned into Callaghan a few years later. Callaghan made the decision to stop paying the lease for the second 2 floors of the building that they had then inherited from IRL, at which point there were already about half a dozen to a dozen startups living there. The startups at the time were very happy having a space that they could use to blow things up and use strange chemicals, so they saw the need to keep it going. That's how level 2 was formed, to hold the lease of those 2 floors, and we've kind of grown from there.
That's cool. And what kind of companies do you have in there? And deep tech is a phrase that's been used a couple of times. It sounds really cool. Well, how do you describe and define deep tech?
So we use Hello Tomorrow's definition of deep tech, which is deep technology are innovations that have the potential to truly advance technological frontiers, and they are based on scientific advancements or engineering innovations. So it's not the kind of all you need is a desk and a laptop to get an app going kind of startup. It's the startups who are pushing scientific boundaries. They are truly, truly innovative. And yes, it's a very broad definition, but that's how we like it. Deep tech contains everything from clean tech to biotech to agri-tech, but also things like drone tech and hardware and IoT and machine learning. So it's quite broad, but it's the stuff that's going to change the world.
And what does it physically look like when you wander in there? Are there actually kind of, like experiment spaces, or is it a lab environment, or how does it? Are there kind of like old rocket burners sitting around?
There actually are. We still have some shrapnel on the walls from some of Peter Beck's early experiments. It's 2 floors of an old building that has been refitted and repurposed to be lab and workshop spaces. So we've got 16 companies in there at the moment. Most of them have their own lab or workshop space. You walk down the corridor, and through one glass door, you get to see Mint's lab. Just across the corridor is Dotterell Technologies' workshop. And that's part of the beauty of the place. If you need to borrow some equipment, if you need to ask for some advice, you've got everyone there who has that knowledge just down the corridor from you.
Must make for a good work Slack. Who left the arsenic in the fridge?
That's probably us.
So maybe talking about them, about the Mint innovation piece as an example of the kind of companies that are there. So you mentioned briefly that you were turning e-waste into the rare earth materials that are found in it. How do you do that biologically? Like, are we talking about a big vat with like liquid with interesting microbes in it that eat everything, or how does it actually physically go? What's the process?
That's essentially it. You're absolutely right. So, process-wise, we recognise that your laptop, for example, contains a lot of gold, contains palladium, contains, as you say, some rare earth metals. The challenging thing is that these are locked up in a pretty complex matrix of other metals, plastics, ceramics, all sorts of other clever stuff. But what's happening with these things is they're typically thrown into a landfill. Bit of acid rain, or a bit of rain mixed with the acidic environment of a landfill, leaches out the metals and it gets into the waterways. So it's got to stop. This hazardous materials are being banned from landfill all around the world. And what we're doing is simply diverting that material and capturing the value from it. We take the printed circuit boards, the green board that's inside laptops, inside servers, even inside your phones. We grind it up. We dissolve all the metals into a solution. So we use a mixture of acid and a mild oxidant just to dissolve everything into a dilute solution. We separate the solids from the masses. And then we use microbes, our magic microbes, to go into that solution and gobble up all the gold. And they literally go in there and they're like a sponge. They soak up the gold, and because they've got mass, you can separate them out. And what we've got is a clever way of selectively concentrating the gold from very, very low concentration. Your laptop's containing a few hundred parts per million, and we want to concentrate that up to a few percentage points. And that's what these microbes do. So you've got this very, very concentrated microorganism. It's mainly carbon, hydrogen, nitrogen, oxygen. Just burn it away, and it leaves gold nuggets. Thanks
for all your work. Please step into this incinerator.
Yeah, we feel a little bit bad about it. But the beauty of this is, these microbes. You can grow a kilo of microbes on 3 kilos of sugar. 3 kilos of sugar, what's that? $10, and a kilo of microbes is able to absorb tens of grams, even hundreds of grams of gold.
And what was the process before? Because I understand that the other thing that, it's a remarkable innovation because of using microbes to selectively harvest the gold out of this. But also, I was reading that the other thing was that at the scale that you're able to do it, you can do it at a scale that's wildly affordable compared to the existing methods. What are the existing methods?
Sure. So existing methods is kind of evolved over time. There's a recognised need for this because these things printed circuit boards are going to landfill. What currently happens is they get aggregated by local recyclers who collect all of the computers, the servers through office disposal systems, through local pickups, that sort of thing. Break all the computers down into different fractions, different waste streams. You've got your plastic streams, you've got your metal framing streams, you've got printed circuit boards. They take the printed circuit boards, they'll fill a container, they'll send that container off to somewhere typically Northeast Asia, and if it's done correctly, those printed circuit boards will go into a smelter. The smelter is typically a copper smelter, burns all the plastic away, smelts the copper away, and then the gold and some of the other precious metals can be collected as a slag material and then refined. The challenge with this is it needs to be done on a continental scale, so they require tens of thousands of tons of material on an annual basis. So that requires all of New Zealand's waste, all of Australia's waste, most of Europe's waste coming to a single smelter just to be economic.
And it sounds like if you're talking about parts per million of the things you want, it sounds like there'd be an awful lot of plastic and stuff burnt away as a waste product.
Absolutely, and when you're burning these things, there's a lot of nasties.
You want Lanzatech at the top of the stack.
Correct, yeah, and that at the moment that is the only cost-effective solution. But what we've done is develop a very low-cost solution that can actually be done at the scale of a city scale. So rather than packing up shipping overseas, which is highly problematic, expensive, lacks transparency, and as you point out, doesn't seem to be the cleanest way of dealing with this waste. What we enable is doing it in the city of collection and able to be cheaply processing it, so we're able to return larger returns to the recycler. We're able to do it cleaner, and we're also able to do it in a cost-effective way that means that we win as well.
It's quite remarkable, isn't it? Like when you see a little bit of tech that just 10 years ago was the absolute, pinnacle of what we've achieved, and now people don't even know how to throw out.
Sure.
Old computers, old circuit boards, and the rest of it, and to be able to get that value back out of it. What happens with your waste in that part? You're not burning it off, but there must be an output.
Absolutely, there are outputs. So we collect all the metals, we collect the copper, we collect all the gold, palladium, and the other interesting metals, and then we separate out the plastic, the epoxy fraction. At the moment, we do consider that a waste stream, but we're working with other partners to look at value add ideas for that. So locking it up into a solid matrix, so you can make furniture, to make railway sleepers, that sort of thing. So absolutely, we're looking to minimise waste. But it's a really interesting point you make about computers that have been the leading edge of kind of the technology revolution for the last 30 years. And it's only now that we're really realising the damage that all of this waste is doing, and it's only now that it really proliferates. We all carry around future waste in our pockets, and so it's taken 20, 30 years to really come up with a solution for that can be deployed on a sensible level and can be made into a way that everybody wins from a financial perspective. I've no doubt we're going down exactly the same track with electric cars, for example. These batteries that we're putting in electric cars. Fantastic global revolution. It's going to change the way that we use cars, but there's going to be waste streams that just aren't economic to be dealt with today. It's going to be 20 years down the track before there's companies like Mint who are able to process these things, and that's somewhat frustrating. We really should be taking a slightly more pragmatic view when we develop these technologies.
Oh boy, and also so many of these rare materials, they come with some horrendous extraction, often horrendous extraction practices. So anything that can keep things in the system rather than destabilising small countries and the like.
Absolutely, yeah, and I think we are as a global economy starting to think about this more, and it's good timing for Mint. That's exactly what we do. We take valuable and scarce metals back in to be recycled, and there's an opportunity. There's great opportunities for more companies like us to be effectively recycling value back into the local economy.
And so how does your company work in with the level 2 idea and with this kind of innovation precinct, and how are you, what kind of benefits are there involved?
Sure, the benefits are literally endless for us. So Lanzatech used to be housed in this building, as you pointed out, and as they moved out, we found a small space. Lanzatech used to take the whole floor. We just take a small office in this place. As Lanzatech moved out and as other companies moved out, they've left lab infrastructure that they can't take with them. So we benefit from the lab type infrastructure. Equally, there's clean space. There's space that has nothing in. So it's flexible for us to be able to build a pilot plant, for example. So the building's well consented. So it's got extraction. So you can do chemical processes. You can do biological processes. So we can literally walk in, and it's a turnkey solution. We can do our tech development from proof of concept stage all the way up to pilot stage in this fit-for-purpose environment. Then the community benefits are even greater. There's companies who've raised very, very large amounts of money. Rocket Lab is one. Peter Beck is still involved in some way with Level 2. He's raised hundreds of millions of dollars. Sean Simpson's raised hundreds of millions of dollars. There's other companies who are there growing today, and they've raised tens of millions of dollars. So having access to their networks, having access to their expertise is you can't buy that sort of thing. You literally can't buy that sort of advice in New Zealand. Then there's IP advice. There's who's the best lawyers, who's the best advisors for this. How do you leverage this grant? How do you work with Callaghan? All of these things, they're intangible but invaluable, and you literally can't buy that sort of information in New Zealand. And it's all free at Level 2.
And I imagine that after, you would have been looking after the patent process for hundreds of international patents in your past role with Lanzatech, I imagine you're a pretty handy guy to have a chat with for quite a few people there too.
Absolutely, and it's all informal advice, but people do come to me to understand the patent process better, who to go to, what can be filed, what can't be filed, and it's my advice can be bought is you should go to a patent attorney firm, but getting it for free as a startup company when you're running on a smell of an oily rag is invaluable to all these other companies. So absolutely.
In terms of kind of the community aspects as well, what kind of happy accidents happen where people share information, or have you had kind of interesting collaborations in the space, or what's the kind of collegial or I guess like academic kind of atmosphere of sharing knowledge?
Sure, there are happy coincidences all the time, and we share resources, we pool resources, we share health and safety protocols, we share investment advice, all that sort of thing. There are new companies that get founded as a result of conversations in the tea room. There's a company that's going through investment at the moment who's a founder of one of the existing companies, met up with another a tech developer who's keen to be involved in that sort of space, and it just grows organically from there. So it's just a random meeting of a bunch of very smart people with a bunch of skills that are pretty unique in New Zealand.
How do people get involved? Like, how do companies come to you?
Usually it starts with an email to me saying, hey, we're looking for some space and advice. How can you help? And then it's a very bespoke process from there on. We don't have a cookie-cutter approach to how we onboard new companies at all. We try and accommodate companies in a way that best suits the founders and the tech and the team. So for some companies, all they need is some space and to be left alone, and we're very happy to do that. For others, they need a little bit of investment, they need a little bit more mentorship, and we provide that too. So it's super founder friendly. We don't have a set program as such, because we find that that's not necessarily what founders need at this stage.
And I think the point you raised earlier is level 2 is a tech incubator, and we're not really level 2 is not really an incubator in that sense of the word. It's merely a space to enable you to do everything you want to do. Everything's on tap, everything's on hand for you to be able to grow in the way that you need to grow. But there aren't formal kind of courses or wraparound services that your typical incubator might have. So it's much more flexible. It's much more kind of tech agnostic, and enables people to kind of grow in the way they need to grow. Level 2 can provide advice and can provide access to the various resources, but it's not forced on you. So that's a pretty nice, comfortable place to grow a company.
And what are the plans for the future? Like what's coming out next?
So we're in the process now of building 8 new lab spaces on the ground floor of the building. There's so much demand for space because New Zealand's really good at generating new ideas. So we have more demand for space than we have space available at the moment. So that's the next thing for us, is to expand the labs and workshops so that we can accommodate more companies. The idea is that in the very long term, we might be able to take over the whole building, but we'll see how that goes. The next thing for us is also to start taking a bit more of an active role in helping out really earlier stage companies. Up until this stage, it's been a bit of a rent-a-lab situation. Usually when companies come to us, they have their first investment round behind them. We'd like to be able to help companies out that are slightly earlier than that. So to provide that pre-seed funding, to provide that really early stage investment. So that's the next step for us, is to take a bit more of an active role in earlier stage investment in these companies.
That's so cool. And if anyone is listening and they're thinking, boy, that sounds like an exciting place, I'd love to just go and see what's going on, or if people have got companies that they think meet the thing, how do people get in touch?
Well, we can look us up anywhere, really. You can look us up on LinkedIn. We have a website that's about to go live. You can flick me an email. Can I say my email address? You can flick me an email on imche@level2.tech. That's IMCHE at level2.tech. You're always very welcome to come for a tour. You can't just wander in. Everything is under lock and key for good reason. But if you ask nicely, I'm more than happy to show you around.
That's so cool. Well, thank you so much, Imche Fouri, and thank you very much, Dr. Will Barker, CEO at Mint Innovation. Can't wait to see what comes out next.
Very good, thank you.
Thank you.
Great. Thank you very much to Tina Tiller for producing. Thank you for listening, and thank you to Callaghan Innovation for sponsoring the podcast.
You've been listening to Business is Boring, presented by Simon Pound. And brought to you by the Spinoff and Callaghan Innovation.
From the Spinoff Podcast Network, that was Business is Boring, brought to you by SparkLab. Make sure you're following Business is Boring wherever you get your podcasts. And for more information on SparkLab, visit sparklab.co.nz. Ready to rediscover the joys of cycling? With over 300 kilometres of cycle paths across Tamaki Makaurau, jumping on your bike and going for a ride is such a fun way to discover the city from a different perspective. Cycling is getting more and more popular across Auckland, so now's a great time to join the hype and give cycling a go. Head to at.govt/cycling to find your nearest cycleway today. The Spinoff Podcast Network.